Good. So now we're on question 9, which is this fantastic thing of logs and series all wound up together like a great roller coaster of maths fun. An arithmetic progression has first term log base 2 is 27, log base 2 is 27, and common difference log base 2 of x. Show that the fourth term can be written as that. This, I mean, the thing is here, it starts off, you just feel what is going on, don't you? They've used lots of words, and you take a deep breath and just actually realise that it's nowhere near as complicated as it feels. It's an arithmetic progression. Let's just write down what we normally write down for that. With the first term A is log base 2 of 27. I'm definitely not going to stick that in the calculator and evaluate it. I'm going to leave it like that. The common difference is log base 2 of x. And the fourth term, well, the fourth term of an AP, we've got a formula for this, haven't we? We've got a formula that says that U4 is A plus 3 times D. So let's just fit that with what we already know. That's A plus 3 times D. There it is. And we can now apply those laws that we just talked about putting on our poster to try and do something with this. Before we think about adding them, remember that formula that we wrote down, it has a 1 in front of both of those terms. So before we can apply this rule, we need to have it as 1 times log base A of x plus 1 times log base A of y. So to start with, that 3 is a bit of a problem. But that third rule that we wrote down means that we can write the 3 there as being log base 2 of x cubed. Now it fits our neat pattern of log base A of x plus log base A of y. We can add it. That is log base 2 of 27 times x cubed. And that, I'm hoping, is what they said. It is. So there we go, that was 3 marks there. You kind of feel that most of those marks were for avoiding panic. Because once you actually got into what was going on with it, it wasn't nearly as bad as it seemed. Now we're told that the fourth term, this is the fourth term is 6. So we need to find the exact value of x. So we're given some more information now. We're told in part 2 that log base 2 of 27x cubed is actually equal to 6. Now again, you know, we've remembered, we've learnt how logarithms work. So using the first thing we wrote down here, we can kind of work backwards from this, can't we? We've got log base A of c equals b. That means a to the b equals c. So this statement here means that 2 to the power of 6 is equal to 27x cubed. 2 to the power of 6 would be a number. Sorry? Oh, of course it is. Yeah, I was trying to do 6 to the power of 6 in my head and think, I'm not going to do that now. 2 to the 6 is, oh, you've got fingers for that kind of thing. So that's 2, 4, 8, 16, 32. Yes, 64 is 27x cubed. Did somebody just say, have you got 64 fingers? If we rearrange this, we've got 64 over 27 is x cubed. So x is the cube root of that, and they are both nice cube numbers, aren't they? So x would be, cube root of 64 is 4, cube root of 27 is 3. That all worked out right in the end, didn't it? As being 4/3. Okay, so that's nice. We've just got a nice 5 marks from that. Now remember, this A and B thing, part A was about arithmetic progressions and had lots of log stuff in it, but part B, so this is a similar kind of theme, but we're not carrying any of our answers through to this. This is starting fresh. A geometric progression has first term log base 2 of 27. So we're starting again now with a geometric progression. First term is log base 2 of 27. And the common ratio is log base 2 of y. Find the set of values of y for which the geometric progression has a sum to infinity. Again, check back to the formula booklet. The formula booklet says the sum to infinity exists if the modulus of r is less than 1. So this is true if log base 2 of y is less than 1. Or the modulus of that. So we're not really used to doing stuff with modulus. That means that, doesn't it? It means log base 2 of y is between -1 and +1. Okay. So let's think about what this means. Let's work on these two statements. Maybe let's work on them separately. This one, log base 2 of y is less than 1. Well, if log base 2 of y is equal to 1, that is 2 to the 1 equals y, isn't it? So that would be that we're dealing with that kind of thing. Now, do we want this to be which side of the inequality sign do we want this to be? Think about, do you remember our log graph, what that looks like? The log graph is the one that goes like that, isn't it? And we're looking here for it being between -1 and +1, the result of that. Now I've kind of changed the axes around here, so this is what y would be. So it's log, I'm dealing with log base 2 of x between -1 and +1. So there, we're saying that value there is at 2, and we also need to know that value there. So we've got y is less than 2, so that fits the upper bit. That's dealt with that bit there. We've also got it to be greater than -1, so we need to think about that bit as well. If log base 2 of y is greater than -1, then that is that's 2 to the -1, isn't it? And we would want y to be greater than that. We can see that from the graph that we're looking at. And 2 to the -1 is a half. So we're ending up with that value there being at a half. 2 to the -1 would be a half. And so we've got y has to be between half and 2 to give that result. I think the graph there was the key thing to sorting out, wasn't it? The graph, remembering the shape of our log graph, helps deal with that one. That was, I mean, this is, the last part of the last question, so that was quite a tough start. Now, find the exact value for y for which the sum to infinity of the geometric progression is 3. So bearing in mind y has to be between a half and 2, we've now also got, in part 2, that the sum to infinity is equal to 3. Sum to infinity is a over 1 minus r. So how can we fit that with what we know about here? A was log base 2 of 27. 1 minus r, that's 1 minus log base 2 of y, and that's going to be equal to 3. We've got quite some sorting out to do with this, haven't we? Before we do anything else, we're going to remember we're not going to change that log base 2 of 27 into a decimal, because the question said find the exact value. We've got an unknown on the bottom of the fraction, so I've got to multiply both sides by this fraction, by this denominator here. So we've got that. Now let's keep going with this. We've got log base 2 of 27 is 3 minus 3 log base 2 of y. Now remember, a little bit earlier, it was helpful for us not to have a 3 in front of the log. And that again applies. It's helpful not to have a number in front of that log term there. So let's write this as being log base 2 of 27 is 3 minus log base 2 of y cubed. I think our best bet is to collect all the things that relate to logs together as a single term. So let's bring this over to this side again. We've got log base 2 of 27 plus log base 2 of y cubed is equal to 3. And that gives us log base 2 of 27y cubed. And that is equal to 3. And we're nearly there. This would be 2 cubed is 27y cubed. So 27y cubed is 8. Are we happy with that? 2 cubed would give us 8. Divide by the 27. And finally cube root it. And we've got y as being... Is that right there? Oh, of course it is. Thanks. Got y being 2/3. One thing to watch out for is if at the end of a really long question that's taken so much of the page that it won't let you extend the page anymore, don't fall into the trap of just getting lazy at the end and saying that 27 cube rooted is 9. Only a fool would do that. So just kind of watch the detail. Anyways, is 2/3 all right as an answer? Didn't we say that y had to be between 1/2 and 2? It is. 2/3 is between 1/2 and 2. I was a little bit nervous when it said 2/9 because I knew that that was less than 1/2. So I'm glad you pointed it out. Let's stop.